In this video we are going to teach density and how to find the density of regular objects like cones, cylinders, spheres which have well-defined shapes. And in the next video we work on density and volume of irregular objects like rocks or a piece of gold, etc. So let's first define density itself. What is density? Let's begin with a question. Is iron heavier or wood? Most of you may instantaneously answer that iron is heavier, but I didn't specify how much wood and how much iron. Maybe I mean this much of wood and just a very small amount of iron. So it's pretty clear that in this case wood is really heavier than iron. But your answer was not that much illogical to me. For solving this question you may have considered exactly wood and iron at the same size. For example, you may have considered 1 meter cubed of iron and 1 meter cubed of wood, or 1 centimeter cubed of iron and 1 centimeter cubed of wood. I mean, you have considered both of them at the same size. If this is iron and this is wood, it is pretty clear that the mass which exists in 1 centimeter cubed of iron is more and greater than the mass which exists in 1 centimeter cubed of wood. This is the definition of density. Density tells you the same thing. Density tells you the amount of mass which exists in 1 unit of volume. This 1 unit can be centimeter cubed or 1 meter cubed. So if we show density by rho, density is equal to m over v. So the amount of mass which exists in 1 unit of volume. So what is the unit of density? Because density is defined as mass over volume, the unit of density can be written as kilograms over meter cubed, which actually this one is in SI units. But it can be written in other units like gram over centimeter cubed, gram over liter, or kilogram over liter, or etc. But you can convert one to another by chain link conversion, as we taught already. So let's go through a question. Prove that 1000 kilogram per meter cubed is equal to 1 gram over centimeter cubed. In this question, a unit of density is converted into another unit of density, and the question is asking us to prove that. For solving this question, we can use chain link conversion as we taught in the past videos. So we know that 1 kilogram is equal to 10 to the 3 grams. And from another side, we know that 1 centimeter is equal to 10 to the minus 2 meters. But what we need is centimeter cubed. So we raise both sides of this equation to power 3, and what we gain is 1 centimeter cubed is equal to 10 to the minus 2 times 3 is minus 6 meters cubed. This is the second equation that we need for solving this question. Okay, we use the chain link conversion and write 1000 kilogram over meter cubed times, we make a fraction. At the bottom we write kilogram and we use the first equation. So the kilograms cancel and at the top we write grams. Okay, the number associated to kilograms is 1 and the number associated to grams is 10 to the 3. Okay, times, we make a fraction again and we write meter cubed top, so that meter cubed from top and bottom cancel, and centimeter cubed at bottom. So the number associated to meter cubed is 10 to the minus 6 and the number associated to centimeter cubed is 1. So as you see, kilograms cancel, meter cubed cancel. So what is left is 1000, which we can write it as 10 to the 3 times 10 to the 3 times 10 to the minus 6 grams over centimeter cubed, which is equal to 10 to the 0, and we know that 10 to the 0 is 1 gram over centimeter cubed. We don't suggest you memorizing these relations because there are lots of relations like these that you cannot memorize all of them. So the thing that is suggested to you is actually learning how to convert one unit to another unit by chain link conversion. But I've written this conversion for those who have basic introduction to chain link conversion. If you want to do this conversion a little faster, you can use another method. Well, you can do it easily by writing 1000 kilograms per meter cube is equal to 1000 times, instead of kilo, you can write 10 to the 3. Instead of meter, we know that 1 meter is equal to 10 to the 2 centimeters. So 10 to the 2 to the power of 3 is 10 to the 6 centimeters cubed. So as you see, the top is 10 to the 6, because 10 to the 3 times 10 to the 3, and at the bottom is 10 to the 6, so the answer is 1 gram over centimeter cubed. So keep in mind that for converting 1 kilogram per meter cubed to gram per centimeter cube, you just can divide it by 1000. Okay, let's go through a question. The density of an iron is 7,800 kilogram per meter cube. What is the volume of 78 grams of iron in centimeter cube? Okay, you can pause the video here and think about the answer, and after finding the answer, replay the video again. Okay, the question tells you that the density of iron is 7,800 kilograms per meter cube. So we write rho is equal to 7,800 kilograms per meter cubed. And the mass of this iron is 78 grams. So we write M is equal to 78 grams. So we should find the volume. But we know that the density is equal to mass over volume. If you want to find volume, you can use this equation and you can write volume is equal to mass over rho. Okay, but you must pay attention that the units in the question do not match. The unit of density is kilograms per meter cube and the unit of mass is gram. So they cannot cancel. You must convert, for example, gram to kilograms, or the unit of density kilograms per meter cube to grams per centimeter cube. So since the question wants us the answer in centimeter cube, for convenience we can convert the unit of density kilograms per meter cube to grams per meter cubed. Okay, from the last page we know that for converting kilograms per meter cube to grams per centimeter cube, you just divide it by 1000. So if you want to convert the unit of density, which is written in kilograms per meter cube, to grams per meter cube, you just divide by 1000. And it is, if we divide it by 1000, the answer is 7.8 grams per meter cubed. Now we can find the volume easily. Volume, as we said, is equal to mass over rho, which is actually, we know that the mass of the object is 78 grams and the density of the object is 7.8 grams per centimeter cube, and grams, as you see, cancel, so the answer is 10 centimeters cubed. So the volume of 78 grams of iron is 10 centimeters cubed. Okay. Now let's go to the next question, which is actually a little more difficult. What is the mass of 20 liters of a fluid of density 1200 kilograms per meter cubed? And the question has given you a conversion factor between liters and meters cubed. So we write V is equal to 20 liters. You can use this conversion factor later. Okay, the question has given you the density of the fluid 2. It is equal to 1200 kilograms per meter cube. So from the equation rho is equal to m over v, we can find m. M is equal to density times volume. But if you want to just multiply rho and v, you see that the units do not match. One is meter cubed and one is liters. So we must convert, for example, V, the unit of volume to meters cubed. So we can write 20 liters as 20 times 10 to the minus 3 meters cubed. Okay, so as you see now, the units can cancel meters cubed with meters cubed. So we multiply density by volume. M is equal to 1,200 kilograms per meter cubed times 20 times 10 to the minus 3 meters cubed. As you see now, meters cubed cancel, so if you multiply these three factors, 12 times 2 is 24, and 1000 times 10 to the minus 3 is 1. So the answer is 24 kilograms. So consider that, for example, if the unit of density was kilograms per meter cube and the unit of volume was liters, they couldn't cancel. But when you convert them, they can cancel. Okay, let's talk about volume of regular objects. If you want to calculate the density of a regular object, an object which has actually a very well-defined shape like cones, cylinders, you have to know their volume. So if A, B, C are length, width, and height of a rectangular cube, we know that its volume is A times B times C. And for a cube, we know that its volume is A to the 3. And for a sphere with radius R, the volume is 4/3 of pi times R to the 3. And for cylinder with radius R and with height h, its volume is pi R to the 2 times h. And we know that pi R2 is equal to area of the base. So the volume of a cylinder is equal to area of the base times h times height of the cylinder. Okay, for a cone, if the radius of the cone is r and its height is h, its volume is 1/3 of pi r to the 2 times h. And we know that again pi r2 is the area of the base. So you can use these equations and you can solve more questions about density. Now let's go through a question. The area of a cylinder base is 25 centimeters squared and its height is 10 centimeters with density of 7,800 kilograms per meter cube. Find the mass of the cylinder in kilograms. Okay, what you need is to find the mass of the cylinder in kilograms. You can pause the video and think about the answer. Okay, for answering this question, we at first sketch a cylinder. And we know that the volume of a cylinder is equal to area of a cylinder base times its height. So the volume is equal to pi r to the 2 and pi r to the 2 times h, and we know that pi r to the 2 is actually the cylinder base and h is the height of the cylinder. The question has given you this term. It means the area of the cylinder base, which is 25 centimeters squared, and its height is 10 centimeters. So 25 times 10 centimeters is actually the volume of the cylinder, which is 250 centimeters cubed. And the question has given you the density of the cylinder too. The density is equal to 7,800 kilograms per meter cube. So as you see again, the units do not match, meters cubed and centimeters cubed. So you need to convert one to another. You can either convert the unit of density or the unit of volume. But for convenience, we can convert the units of density, and if you convert it to grams per centimeter cube, you must divide that by 1000. So the answer is 7.8 grams per centimeter cubed. Now, as you see, the units match and centimeters cubed can cancel. So we write m is equal to density times volume, and density is 7.8 grams per centimeter cube, and volume is 250 centimeters cube. So as you see, again, centimeters cube cancel from top and bottom, and if you multiply 7.8 times 250, the answer is 1950 grams. But since the question wants us the answer in kilograms, you can divide it just by 1000, or you can use chain link conversion, and if you find the answer, it is 1.95 kilograms. So the mass of the cylinder is 1.95 kilograms. Now pay attention to a more difficult question. In a metal sphere of radius 10 centimeters, there is a hollow sphere of radius 5 centimeters. If the density of the metal is 8 kilograms per liter, calculate its mass in kilograms. The question has given you the pi is equal to 3. This is a more difficult question because you not only need to do unit conversion, but you also have to calculate the volume of a sphere which has a hollow inside it. So for solving this question, you'd first have to sketch the metal sphere at first. This is the metal sphere of radius 10 centimeters. Okay? So in this metal sphere, we have a hollow sphere with radius 5 centimeters. So we need to find the mass of this object, but we know that mass is equal to density times volume. So we need to calculate the volume of this object. So if I color this object with blue, we must calculate the volume of this object at first. So we must find the volume of a space which is colored in blue. For finding the volume of this part, we must first find the volume of a filled sphere with radius of 10 centimeters, and then find the volume of a hollow sphere with radius of 5 centimeters, and then subtract the volume of a hollow sphere from a filled sphere. So the volume of the bigger sphere, which its radius is 10 centimeters, is equal to 4/3 of pi r to the 3, and we know that r is equal to 10, so 4/3 of pi, 10 to the 3, and the question has given you pi is equal to 3, so pi 4/3 of 3 times 1000, which is equal to 4000. So the volume of the bigger sphere is 4000. So this is the volume of bigger sphere with radius 10 centimeters without considering this hollow sphere. So we must find the volume of this hollow sphere too and subtract it from the bigger sphere. Okay, if we call the volume of the bigger sphere V1, we can find the volume of the hollow sphere, we can call it V2, V of 2, and V of 2 is equal to 4/3 of pi is 3 times its radius is 5 to the 3. Okay, so if you multiply these three terms, the answer is 500 centimeters cubed. So we have the volume of the bigger sphere, and we have the volume of a hollow sphere. So the volume of the blue color is equal to V1 minus V2, which is equal to 4000 centimeters cubed minus 500 centimeters cubed, which is equal to 3,500 centimeters cubed. And this is the volume of blue region. But what the question is asking us is calculating the mass of this object in kilograms. So what we need to do is multiplying density by volume. But we know that the volume of this object has been calculated in terms of centimeters cubed. So you need to convert it in meters cubed, and you should convert the unit of density to kilograms per meters cubed too, so that the units match together and cancel each other. So for converting the volume of this object in meters cubed, we write 3,500 centimeters cubed is equal to 3,500 times 1 centimeter is 10 to the minus 2, and because centimeter has been raised to power 3, we raise it to power 3. So the answer is 3,500 times 10 to the minus 6 meters cubed. But you need to convert the units of density from kilograms per liter into kilograms per meter cubed. So we write 8 kilograms per liter is equal to 8 kilograms, and instead of liter you can write 10 to the minus 3 meters cubed. So 10 to the minus 3 when it comes to the top becomes 10 to the 3. So 8 times 10 to the 3 kilograms per meter cubed is the density of this object. Now as you see, the units match together. Meters can cancel. Okay, for finding the mass, you just need to multiply density by the volume of this object. So we write mass is equal to density times volume, and we know that the density is 8 times 10 to the 3 kilograms per meter cubed times 3,500 times 10 to the minus 6 meters cubed. So as you see, now meters cubed can cancel, but if you didn't do unit conversion, they couldn't cancel. And the final answer is 28 kilograms. So the mass of this sphere with a hollow sphere inside it is 28 kilograms. This was actually a difficult question because you needed not only to do unit conversion but also find the mass of an object with a hollow sphere inside it. Okay, now let's solve a similar question related to hollow objects. In an iron hemisphere as figure, a hollow hemisphere has been made. If the density of the iron is 8 grams per centimeter cubed, what is the mass of this object? So the question wants us to calculate the mass of this object. But you must consider that this is a hemisphere, and we know that the volume of a hemisphere is half of the volume of a sphere. First thing first, you can imagine that the hollow hemisphere that you see here does not exist. And you just need to find the volume of the bigger hemisphere. And we know that the volume of a hemisphere is equal to half of the volume of the full sphere. So, for finding the volume of the bigger hemisphere, we write V is equal to half of the 4/3 of pi times r to the 3. But let us call the volume of the bigger sphere V of 1. So V of 1 is equal to half of 4/3 of pi, which is 3, times radius of hemisphere. And as you see in the figure, the radius of hemisphere is this part, which is equal to 3 plus 2, which is equal to 5 centimeters. So the radius of the bigger hemisphere is 5 centimeters and 5 to the 3. So if you find the answer, as you see, 3 cancel and the answer is 250 centimeters cubed. 2 times 125 is equal to 250 centimeters cubed. Okay, we have the volume of the bigger hemisphere. Now we need to find the volume of the hollow hemisphere, I mean this part. Let us call that V of 2. So if you call the volume of this part V of 2, the volume of the hollow hemisphere is equal to V of 2 is equal to half of 4/3 of pi times r to the 3, which is equal to half of 4/3 times 3, pi is 3, and the radius of the hollow hemisphere is 2. So as you see, 3 cancel, and the answer is 16 centimeters cubed. So as you see, we have found the volume of the bigger hemisphere, and we have found the volume of the hollow hemisphere too. So the volume of the part which is colored in blue is equal to the volume of the bigger hemisphere minus the volume of the hollow hemisphere. So 250 centimeters cubed minus 16 centimeters cubed, which is equal to 234 centimeters cubed. And this is the volume of the part which is colored in blue. And this is what we need to solve the rest of the question. The question wants us to calculate the mass of this object. And we know that the mass is equal to density times volume. So we have the density, which is 8 grams per centimeter cubed, times volume of this object, which is 234 centimeters cubed. And as you see, centimeters cubed cancel from top and bottom. And the final answer, if you multiply these two terms, is 1,872 grams. And if you want to convert the mass of this object from grams to kilograms, you just need to divide this number by 1,000. So the mass of this object in kilograms is 1.872 kilograms. Okay, now let's solve a more difficult question, which is similar to these problems. In a piece of gold of volume 12 centimeters cubed and a mass of 199.5 grams, there is a hollow. If the density of the gold is 19,000 kilograms per meter cubed, what is the volume of the hollow in cubic centimeters? Okay, you can pause the video here and think about the answer. Now let's go through answering the question. The question has given you the volume of the gold, which is 12 centimeters cubed, and didn't specify any kind of shape for that. So you yourself can sketch a very optional object, a very optional form for the gold. Consider this, for example, the gold, which is 12 centimeters cubed. The question is telling you that there is a hollow inside this gold. So the part that you see that I'm filling that with black is full of gold, and the center part of this gold is a hollow. So what is the volume of this part which I have filled with black? The volume of this part is equal to 12 centimeters cubed minus V prime. And V prime is the volume of the hollow. So we can call the volume of the black color V, and the question is asking us to find the volume of the hollow, which is actually V prime. And the mass of this piece of gold is 199.5 grams, and its density is equal to 19,000 kilograms per meter cubed. But we must convert the unit of density to grams per centimeter cubed. So we divide it by 1,000, and the answer is 19 grams per centimeter cubed. We now use the density equation to solve this problem. We know that the mass of this object is equal to density times volume. So the mass of this object is 199.5 grams, and its density is equal to 19 grams per centimeter cubed times the volume of the space, which is colored in black, which is 12 minus V prime. Okay, as you see, there are grams in both sides, so grams cancel. So for solving this question, you need to divide both sides by 19, and what you get is 10.5 is equal to 12 minus v prime. So v prime is equal to 12 minus 10.5, which is equal to 1.5 centimeters cubed. So the volume of the hollow sphere is equal to 1.5 centimeters cubed. Please share the video so that more people can access free tutorial videos on physics. Have a good day.